In this video, we will practice our basic integration skills. For number 14, we will just integrate term by term using the power rule of integration. So looking at the x to the third power, I increase the power by 1, so that's a 4. Now I divide by the new power. 8 divided by 4 is 2. Moving on to the x squared, this will become x to the third power. Dividing by the new power, negative 9 divided by 3 is negative 3. When you integrate a constant, it just takes a variable. So the integral of 4 will just be 4x. And don't forget the constant of integration. For number 18, I would rewrite the integral first. The fourth root is the same thing as x to the 1/4 power. So that's going to turn x to the third power into x to the 3/4 power. A fractional exponent is always in the form power over root. So that 4 is your fourth root. And we'll just leave the plus 1. So now we can integrate term by term. So using the power rule of integration, I will increase this exponent by 1. And in my mind, I'm thinking plus 4 over 4. So this is going to be 7/4. And then I divide by the new exponent. But dividing by 7 over 4 is the same thing as multiplying by 4 over 7. Integrating 1 just gives me x. And don't forget the constant of integration. For number 22, I'm going to use my a plus b over c rule. This would be the same as a over c plus b over c. So to rewrite this problem, I'm going to divide each term by x to the 4th power and write it separately. X to the 4th power divided by x to the 4th power is 1. And there's my negative 3. When I divide these terms, I will subtract the exponents. So x squared divided by x to the 4th power is x to the negative 2 power. And then 5 divided by x to the 4th power is the same thing as 5x to the negative 4th power. Now I will use the power rule of integration term by term. Well, the integral of 1 is just x. And then I'm looking at the x to the negative 2 power. Increasing the power by 1, I get x to the negative 1 power. And then dividing by my new exponent, I have negative 3 divided by negative 1, which is positive 3. Moving on to the x to the negative 4th power, I'm going to increase this by 1, so this will be x to the negative 3 power. Dividing by my new exponent, I have 5 divided by negative 3, so that's going to be negative 5/3. And don't forget your constant of integration. That's a perfectly acceptable answer. But on a multiple choice question, you might also see the answer written this way without negative exponents. Integrating term by term, t squared will become t to the 3rd power, and then I divide by my new exponent, so I will have a 1/3 out in the front. The antiderivative of cosine. I'm thinking to myself, the derivative of what is cosine? The derivative of sine is cosine, so that is the antiderivative. So I'll just bring down the minus sign. And don't forget the plus c. For number 30, I would first rewrite this by distributing the secant y. So I will have the integral of secant y tangent y minus secant squared y dy. Now I am going to integrate term by term. So in a case like this, I ask myself, the derivative of what is secant tangent? And we learned in first semester that the derivative of secant is secant tangent. That makes this the antiderivative. Moving on to the second term, the derivative of what is secant squared? The derivative of tangent is secant squared. So tangent is the antiderivative. And then you just put your plus c. For the last few problems, we will find the particular solution that satisfies the differential equation and the initial condition. A differential equation is just an equation that has some type of derivative in it. And solving the equation means turning the derivative back into the original function. So I need to turn f prime back into f. We can turn f prime into f by integrating. So technically I am integrating both sides of the equation, but I'm not going to show it. I'm just going to do it. So the antiderivative of f prime is f. And then the antiderivative of 6x, we increase the exponent by 1, and then we divide by the new exponent. 6 divided by 2 is 3. And you include the constant of integration. Finding the particular solution means that we need to solve for c. And we can do that using this initial condition. So f at 0 equals 8. That means if I plug in 0, I should get 8. So I'm going to plug in 0 and set it equal to 8. So the first term becomes 0. So I just have c equals 8. Now I can take this value and put it back into the equation right here. So the particular solution I'm looking for is f of x is equal to 3x squared plus 8. Similarly, the antiderivative of h prime is h, and t to the third power becomes t to the fourth power. Dividing by the new exponent, 8 divided by 4 is 2. The integral of 5 is 5t, and we include the constant of integration. Now we use this initial condition to find c. So h at 1 is equal to -4. In other words, if I plug in 1, if I substitute 1 for t, I should get -4 as the answer. So this is really just 2 times 1, which is 2. So I have 2 plus 5 plus c is equal to -4. But this is 7 plus c is equal to -4. Subtracting 7 from both sides, we find that c is equal to -11. For the particular solution, we will substitute this back in for c. So we get h at t, h at t is equal to 2t to the fourth power plus 5t minus 11. In the chain of calculus, we have f of x, f prime, and f double prime. To solve a differential equation that has f double prime, we need to get from f double prime all the way back to f. So we will have to integrate twice. I will have to go from f double prime back to f prime, and then I will integrate again, and I will get f of x. So let's take the antiderivative of both sides of this tiny equation. The antiderivative of f double prime is f prime. The antiderivative of 2 is 2x plus c. We will now use this initial condition to find the value of c. So f prime at 2 is equal to 5. That means if I plug in 2 for x, it should equal 5. So this means that 4 plus c is equal to 5. Subtracting 4 from both sides, we have c is equal to 1. Now I can put this 1 right here, and I have f prime of x is equal to 2x plus 1. Let's take the antiderivative of both sides again. The antiderivative of f prime is f. Looking at the 2x, the x becomes x squared, and then I divide by my new exponent. But 2 divided by 2 is 1. They cancel each other out. So I guess I don't need so much space. And then the antiderivative of 1 is x. Normally I would say plus c, but we already used the letter c in this very same problem. So we need to use a different variable. Let's use d. So now we need to use the other initial condition to help us find d. So this says f at 2 is equal to 10. So if we plug in 2, we should get 10 for the answer. In other words, 2 squared plus 2 plus d should equal 10. This means 4 plus 2 plus d equals 10. So 6 plus d is equal to 10. Subtract, that looks like a 16. Subtracting 6 from both sides, we get d is equal to 4. So for the particular solution, we will use the d value of 4, and we get f of x is equal to x squared plus x plus 4. Kabam!